Living along the Susquehanna River and working in Pennsylvania, when you talk the bay and what we're trying to achieve with the Chesapeake Bay, a lot of folks will come back to you and say, "But we don't have the bay. I don't live along the bay. I've never been to the bay," or whatever have you. And I say, "No, but the Susquehanna goes right by your community. And if we can do our job to clean up Chickies Creek, the Susquehanna River, ultimately we're going to clean up the bay." And most times the people go, "Oh yeah, oh yeah, I'm concerned about the river, or I'm concerned about the creek in my area." And I say, "Okay, if you do that, ultimately you'll clean up the bay." I think it's great what some folks are doing in states like Virginia and Maryland and all, and the monitoring they're doing.
So up in the watershed, we monitor free-flowing rivers, that is non-tidal rivers. And at each of those sites, we collect water samples from the river and send those off to a lab. And what we analyze for in the lab are nutrients, sediment, and sometimes toxic contaminants. Now, when we're in the tidal waters, that's where we have to collect the samples using a boat. The monitoring tells us a condition of a watershed or a body of water and how that condition changes over time. But we need to explain what causes those changes, and that's where a model is so useful.
And when you start talking about the model, you get that blank stare. It's a guide to simulate where do we want to be in the future and how are we going to get there and can we get there.
You may have heard we've reduced nitrogen, phosphorus, and sediment loads by so many pounds as predicted by the model. But the big question is, what is the model? Let's think about a photograph. And a photograph, if it's really pixelated, you see little blocks. So that's what the models looked like probably 30 years ago. They were our best estimate. But now think about a photograph that you take, but instead they have very small pixels and you're able to really see the picture. That's what the models look like today. They're much finer in their resolution. We use science from leading universities and we bring that into our computer models. And then we also use information such as aerial imagery. And the way we ensure that they're accurate is that we compare them to observations, to data that we collect in the stream.
The monitoring puts bounds on the model. It provides it with reality. So you use the monitoring data as a foundation for the model, and then to calibrate the model, that is to make it as close to reality as possible, you adjust the processes you have in the model to try to match that monitoring data as well as you can. And then the longer we have the monitoring information, usually the more powerful the model can come. So right now we have almost 2 decades of information for the bay watershed and estuary models. So that's why they're so useful in trying to say where do you want to put in practices to reduce nutrients to improve the water quality of the bay.
Once we know the contributing nutrients and sediments to the Chesapeake Bay, we can begin to ask what-if questions. For example, what if we were able to place cover crops on half of our farms? What impact would that have? What if we were able to upgrade our wastewater treatment plants to best technology? How would that change water quality in the Chesapeake Bay? What if we were able to green our communities? We can put those types of scenarios into the model, and that will tell us then what that impact would be in terms of how much nitrogen, phosphorus, and sediment reductions.
If you're starting to talk about stormwater and you look at the model and you say, this is what the future is probably going to look like, okay, how much is it going to cost us to get there where we want to be and have that effect?
If we combine our models, the nitrogen, phosphorus, and sediment reductions, with information on how much these practices cost, we can then identify what are the most cost-effective practices that we can put on the land. That's the value of it, is when you have a verified model that's based on sound science and calibrated to observe data, then you have a tool that is really appropriate for decision makers to use in identifying what they can do in terms of specific practices to improve water quality both locally and downstream to the bay.
You don't want to take taxpayer dollars and just set them aside, but you have to have a rationale for it. Well, the model helps you explain to people where the future is going to go and why we have to prepare for it. If you don't, the future taxpayer is going to be left holding the bag.